Somewhere inside Airbus's headquarters in Toulouse, there's a comfortable assumption that's been repeated for years, almost like an unofficial company motto whispered between executives. China is always a decade behind. Keep saying it enough times, and it starts to feel less like an opinion and more like a fact of life, something you don't even need to double check anymore. But in 2026, that comfortable assumption got shaken in a way that reportedly has people inside Airbus genuinely rattled. And here's what makes it strange. It didn't happen because the C919 suddenly took its first flight. It hasn't flown. It didn't happen because China rolled out a brand new engine ready to compete with anything coming out of Rolls-Royce or CFM. That engine doesn't exist in finished form yet either. Instead, Beijing made a move so quiet, so administrative on the surface, that most casual aviation followers scrolled right past the headline without a second thought. And yet, that quiet move might end up mattering more to Airbus's long-term market position than any flashy technological reveal ever could have. It's the kind of decision that could completely reshape how the rest of the world views China's most ambitious aviation project for decades to come. So what actually happened? Why is Airbus reportedly furious about a paperwork agreement almost nobody outside the industry has ever heard of? And why should you care, even if you've never set foot anywhere near an aircraft factory in your entire life? Stick around, because to understand why Airbus is so uneasy about this, we need to rewind the clock and look at exactly where this program came from. Because the backstory here is honestly stranger than most people realize. Picture aircraft certification like the most brutal driving test you could possibly imagine, except instead of one examiner sitting beside you with a clipboard, you need dozens of them, pulled from multiple regulatory agencies, each one obsessively picking apart a different piece of the aircraft. Every wire gets traced, every bolt gets torque tested, every single line of flight control software gets scrutinized character by character, because if any of it fails at 35,000 feet, there's no pulling over onto the shoulder of the road to sort it out. That is the standard the entire commercial aviation industry lives and dies by. And it's exactly why certification, not first flight, tends to be the real bottleneck for practically any new aircraft, program anywhere on Earth. It's also precisely the part of the business Airbus and Boeing have quietly dominated for decades, the part that keeps new competitors locked out, no matter how good their engineering looks on paper. Now here's something a lot of casual observers tend to forget. This particular Chinese wide-body jet wasn't originally a solo Chinese effort at all. It began life under an entirely different name, the CR929, built on a 50-50 partnership between China's state aviation giant COMAC and Russia's aircraft maker UAC. Two nations with very different aviation histories agreed to split both the enormous cost and the enormous engineering risk of building a wide-body jet completely from the ground up. On paper, it looked like a shrewd move, exactly the kind of alliance that should have worried Airbus far earlier than it apparently did. Russia brought decades of experience building large aircraft dating back to the Soviet era. China brought capital, manufacturing scale, and a domestic market large enough to make the entire venture commercially viable on its own, even before a single export sale. Together, the plan was to build a jet capable of taking on Boeing and Airbus without either partner having to shoulder the full burden alone. Then the geopolitical landscape shifted. International sanctions hit Russia hard, and almost overnight, UAC's access to Western financing, Western components, and Western technology collapsed. Suppliers pulled out. Banks froze credit lines. The infrastructure a modern aircraft program depends on, global supply chains, international insurance, cross-border financing, simply stopped being available to Moscow. And quietly, without a dramatic press conference, without any finger-pointing, Russia walked away from the partnership entirely. No more 50-50 split, no more shared risk. China faced a genuine fork in the road at that moment. It could cancel the entire program, absorb the sunk costs, and let the whole idea quietly fade, the same way plenty of ambitious aviation projects around the world have faded before, sometimes taking Airbus and Boeing competitors down with them. Or it could shoulder the entire weight of the project alone. It chose to shoulder it. The aircraft was renamed, becoming the C929 we discussed today. And every unresolved technical problem, every dollar of financial risk that Russia would have shared, became China's burden to carry by itself. That decision tells you something important about how much this program actually matters strategically to Beijing. Most commercial ventures would have quietly folded the moment a major partner walked away mid-program. This one didn't fold, it doubled down, and that alone should have put Airbus on notice years before Toulouse apparently started paying real attention. Then in 2026, something shifted that most casual aviation fans completely missed, but that people inside Airbus reportedly noticed immediately. China's aviation regulator, the CAAC, sat down with aviation authorities from Hong Kong and from Macau, and the three of them signed something called a cooperation arrangement. Say that phrase out loud, and it sounds like exactly the kind of thing that gets filed away in a government archive and forgotten. It sounds like bureaucratic housekeeping, the sort of paperwork nobody outside a regulatory office would ever bother reading closely. It is not that at all. For the very first time in the program's history, Beijing is inviting outside certification specialists directly into the process of approving its newest, most ambitious, most expensive aircraft. Yet, a genuine wide-body built specifically to compete head-to-head with the Boeing 787, and more pointedly for this story, the Airbus A350 on long-haul international routes. So why Hong Kong specifically, out of every possible partner China could have chosen? The answer comes down to credibility, and credibility, as we're about to see, is really the entire theme of this story, and the exact reason Airbus should be watching closely. Hong Kong's aviation authority already operates much closer to international norms than mainland China's regulatory system does on its own. It follows a framework that lines up closely with the same standards used by European regulators, the very organizations Airbus has leaned on for its own credibility for decades. By training alongside Hong Kong's certification specialists, China isn't simply trying to build a plane faster, it's rehearsing, quite literally practicing, for the moment when the rest of the world has to decide whether it trusts a safety certificate stamped in Beijing the same way it already trusts one stamped in Cologne by EASA. Because here's the uncomfortable truth nobody in the industry says out loud very often. An aircraft can be aerodynamically brilliant, mechanically sound, and still get effectively locked out of major markets if the right regulators refuse to sign off on it. That's precisely the wall Airbus and Boeing have quietly relied on for decades to keep serious new competitors at arm's length. In other words, this cooperation arrangement isn't really about paperwork at all. It's about credibility. And credibility happens to be the one thing that money simply cannot buy in aviation, no matter how many billions get poured into a program, and no matter how many angry meetings it might be triggering behind closed doors in Toulouse right now. So let's talk about where the C929 actually stands today. Because there's a real difference between a headline-grabbing announcement and the physical reality unfolding on the factory floor, and Airbus's own internal assessments almost certainly separate the two just as carefully as we're about to. Here's what's actually confirmed right now. Preliminary wind tunnel testing is underway, and that matters more than it might sound like at first glance. Wind tunnel testing is the first genuine physical proof that an aircraft's shape can slice through the air the way engineers designed it to on paper, long before a single rivet gets installed on a real airframe. It's the moment theory starts colliding with physical reality. Alongside that, COMAC officials are already sitting inside COMAC's design review meetings, weighing in on choices while the aircraft is still being sketched out, not after the design has already been locked in and frozen. That kind of early regulatory involvement has genuinely never happened this soon in any previous Chinese aircraft program, and it suggests Beijing has learned some hard lessons from earlier projects, where certification became an afterthought, bolted onto the end of the design process, instead of being built in from day one. On the commercial side, Air China has put its name down as the aircraft's launch customer, signing a preliminary agreement at the Zhuhai Air Show, China's marquee event for showing off its aviation ambitions to the entire world, including to the Airbus and Boeing delegations that reportedly attend every single year specifically to keep tabs on exactly this kind of announcement. Having a flagship national airline commit early sends a signal, both domestically and internationally, that there's real institutional confidence behind this program, not just political rhetoric dressed up for the cameras. But here's where we need to be completely honest with you, because a channel that only tells you the exciting parts isn't doing its job, and frankly, Airbus knows these numbers better than almost anyone. COMAC's own leadership, speaking publicly at the 2025 Paris Air Show, put the target for a type certificate at 2032, with the aircraft not expected to carry its first paying passenger until 2035. Read those numbers again. That is not next year. That is not even within the next 5 years. For context, when Airbus itself launched the A350 program, it took close to a decade from initial announcement to entering commercial service, and Airbus had over a century of combined institutional experience, building and certifying wide-body jets already behind it before the program even started. Boeing's own 787 program took roughly 7 years from formal launch to entering service, and it still ran years behind schedule and burned through billions in cost overruns along the way. China is attempting something similar in scale and ambition with a fraction of that accumulated institutional experience, while simultaneously trying to construct an entirely new supply chain from scratch. Real progress is genuinely happening here. Nobody serious in the industry, Airbus included, is denying that outright. But we are still standing at the very beginning of what's going to be an extremely long runway, and anyone telling you otherwise is selling you something. Now let's talk about the actual scope of what China is attempting here, because once you see the full picture, it becomes a lot easier to understand exactly why Airbus is paying such close attention. The baseline version, known as the C919-600, is being designed to carry 280 passengers with a range of roughly 12,000 kilometers. To put that range in perspective, that's far enough to connect almost any two major cities on the entire planet without needing to stop for fuel along the way. That figure puts this aircraft on a direct collision course, not with regional jets or narrow-body workhorses, but with some of the most commercially successful long-haul aircraft ever built. The Boeing 787, the Airbus A320neo, and sitting squarely in the crosshairs of the Airbus A350 itself. This isn't a modest regional ambition China is chasing here. This is a direct attempt to compete in the single, most lucrative, most technically demanding segment of the entire commercial aviation market, the exact segment that has quietly generated an enormous share of Airbus's long-term profits for years. And then there's the engine question, which, as of today, remains completely unresolved. There is still no confirmed power plant for this aircraft. And that's not a minor detail you can gloss over. It's arguably the single biggest open question hanging over the entire program. And we're going to come back to exactly why that's such a serious problem in just a moment, because it deserves its own deep dive. On materials, COMAC is targeting roughly 50% composite materials and around 15% titanium across the airframe, concentrated specifically in the areas that experience the most mechanical stress, places like the engine mounts and the landing gear structures. To really appreciate how enormous a leap that represents, consider that China's earlier regional jet program used just 1.5% composite material in its construction. Jumping from that number to 50% is roughly equivalent to a factory that has only ever assembled bicycles suddenly attempting to build a Formula One race car. The manufacturing knowledge, the quality control systems, the supply chain relationships needed for advanced composite work at that scale, simple. I don't exist yet inside China's aviation industry in a mature, proven form. Building them is possible. Airbus itself spent years developing its own composite expertise for the A350's airframe. But that expertise takes years of iteration, testing, and often expensive failure before a supply chain matures to the level of reliability regulators demand. It's worth pausing here to compare this to how other emerging aviation programs have handled similar transitions, because China isn't the first country to try leaping from a lower tier of manufacturing straight into advanced wide-body territory. Japan's Mitsubishi space jet program, despite enormous funding and genuine technical talent, ultimately collapsed after years of repeated certification delays and a fundamental underestimation of how difficult the regulatory approval process actually is. Russia's own Sukhoi Superjet struggled for years to gain meaningful traction in international markets, partly because Western airlines and lessors remained hesitant to trust a certification pathway they weren't fully familiar with. These aren't cautionary tales meant to dismiss what China is attempting. Their context. They show exactly why the Hong Kong and Macau cooperation arrangement matters so much more than it might first appear, and exactly why Airbus's concern reportedly isn't really about the engineering at all. It's about the trust pathway, the one variable that has nothing to do with whether the aircraft can physically fly and everything to do with whether airlines outside China end up believing the paperwork behind it. And then, finally, let's talk about the money, because the financial story here tells you almost as much as the engineering story does, and it's a story Airbus's own finance department has almost certainly modeled out more than once. In late 2024, 8 separate state-owned shareholders poured a combined total of roughly $6.2 billion into COMAC, very nearly doubling the company's available capital in a single move. Think about what that kind of investment signals. In most publicly traded companies operating under normal market pressures, a full decade of delays and missed targets would trigger genuine panic among investors, possibly even outright cancellation of the program to cut further losses. The kind of pressure Airbus's own shareholders would never tolerate for long. Here, in COMAC's case, a decade of delays simply triggers another round of funding, another injection of state capital, another vote of confidence from Beijing. That's both the quiet advantage and the quiet danger baked into a program that's fundamentally built on political will rather than pure market demand. The advantage is obvious. This program will almost certainly never die from a lack of funding the way a purely private venture might, which is precisely why Airbus can't simply assume COMAC will eventually run out of runway and quietly disappear. The danger is less obvious, but just as real. Without the discipline that comes from market pressure, inefficiencies can compound for years without ever being seriously confronted. Put all of these pieces together, the certification cooperation, the design specifications, the composite ambitions, the enormous capital injections, and the real ambition here finally comes into sharp focus. This was never just about building one successful airplane to compete with Boeing and Airbus on a spec sheet. China is attempting to construct an entire self-sufficient aviation ecosystem, from raw materials to finished aircraft to certification authority, all without needing to ask anyone else's permission along the way. That's a civilizational scale ambition, not a product. Launch. And it's exactly the kind of long game that makes Airbus nervous, because Airbus doesn't just compete on individual aircraft sales, it competes on decades-long customer relationships, and any credible new entrant threatens to unravel those relationships slowly over years, long before a single competing jet ever lands at a major hub airport. Now let's circle back to that engine question, because this is genuinely where the ambition runs headfirst into reality, and it deserves a much closer look. A Western engine option, something from Rolls-Royce or from GE, remains technically possible on paper. These companies have decades of proven experience building reliable wide-body engines that airlines around the world already trust. Engines that also happen to power a huge share of Airbus's own aircraft. But that option is politically fragile under current export restrictions, and fragile is putting it kindly. A single shift in the geopolitical climate could take that option off the table entirely, and COMAC knows it. So, in parallel, China is racing to build its own homegrown alternative, the CJ2000, developed by the domestic engine maker AECC. In January of 2026, that engine hit 35.2 tons of thrust on a test stand, a figure that puts it in the same general weight class as established engines like the GE9X. On the surface, that's a genuinely impressive engineering achievement, and it deserves to be recognized as such. But here's the catch that almost nobody likes to talk about openly. Producing a strong thrust number in a tightly controlled test cell environment is a completely different challenge from having an engine that's fully certified, mass-produced at scale, and trusted by airlines to run reliably for millions of cumulative flight hours without unexpected failure. That gap between an impressive test result and a proven, dependable production engine has swallowed entire national aviation programs before in more than one country, and it tends to happen quietly, without dramatic headlines, just years of delay stacking up one after another. In commercial aviation, an unresolved engine decision can silently push back an entire aircraft program by an entire decade, because everything else, the wing design, the fuel systems, the weight distribution, ultimately has to be finalized around whichever engine actually gets selected. There's also a quieter dimension to this engine race worth understanding, because it isn't purely a technical race, it's also a workforce and supply chain race. Building a reliable wide-body engine doesn't just require a design team capable of drafting impressive blueprints. It requires an entire ecosystem of specialized metallurgists, precision machining, facilities capable of working with exotic alloys and quality assurance pipelines refined over literally millions of hours of accumulated real-world flight data. Rolls-Royce and GE didn't build their reputations overnight, and neither did the CFM partnership that powers so many Airbus jets today. They built them across decades of iteration, including plenty of expensive early failures that never made it into glossy corporate history pages. AECC is attempting to compress that same learning curve into a fraction of the time, backed by state resources that Western engine makers never had access to in their own early years. That resource advantage is real, and it shouldn't be dismissed. And it's likely a significant part of why Airbus is reportedly taking this more seriously than it publicly let us on. But resources alone have never been enough to skip the fundamental physics of engine reliability testing. And that's precisely why so many industry analysts remain cautiously skeptical about firm certification timelines for the CJ2000, even as they acknowledge the genuine progress behind that 35.2-ton thrust figure. Look at China's own C919 program if you want physical proof of exactly how long this kind of gap can stretch. That aircraft was certified domestically back in 2022, a genuine milestone at the time. And yet, 4 years later, it still doesn't have approval from Europe's aviation regulator or from America's FAA, the two certifications that would allow it to fly commercial routes into most of the world's wealthiest aviation markets Airbus currently dominates almost entirely uncontested. European officials have suggested that approval could realistically stretch out until 2028, possibly even as late as 2031. That's not a minor bureaucratic delay. That's nearly a full decade between domestic certification and genuine international market access. COMAC's broader delivery record hasn't done much to bolster confidence either. In 2025, the company delivered 41 aircraft across its entire combined lineup, a number that fell well below what it had originally promised to airline customers and investors. So yes, the certification cooperation news out of Hong Kong and Macau is real, and it's genuinely significant for the program's long-term credibility and genuinely worth Airbus's attention. But it represents one bright spot along a much longer, much harder climb than most headlines make it sound. And now here comes the twist. the part of this story that might genuinely change how you look at everything we've just covered, and honestly, the part that might explain the Airbus frustration best of all. COMAC recently signed a letter of intent with a company called Aviation to build the C929's core avionics, essentially the electronic brain that runs the cockpit displays, the flight control systems, every digital process that keeps this aircraft thinking and responding in real time. And here's the surprise buried inside that announcement. Aviation Systems is not a purely Chinese company at all. It's a 50-50 joint venture. One half belongs to Avic, China's state-owned aviation manufacturing giant. The other half belongs to General Electric, an American company headquartered thousands of miles away in the United States. So sit with that for a second, because the irony here is almost poetic, and it's exactly the kind of detail that would make any rival manufacturer's strategy team pause mid-meeting. This is the aircraft that was born directly out of Russia's exit from the original partnership. This is the aircraft China deliberately chose to carry alone rather than risk depending on another foreign partner ever again. This is the program explicitly, designed, at least in the public narrative, to prove that Beijing no longer needs the West for its most advanced aviation technology. And yet, sitting quietly at the very center of that aircraft's cockpit, inside the systems that will ultimately keep it flying safely, there are the fingerprints of an American company, a company whose engines also compete directly with the very jet this avionics deal is helping bring to life. So which version of this story is actually true? Is the C929 genuinely China breaking free from foreign technological dependence, the way the official narrative wants you to believe? Or is it something more nuanced? China simply becoming far more selective and strategic about exactly who it's willing to depend on. Next, rather than eliminating dependence altogether. Personally, I think the honest answer sits somewhere in between those two extremes, but I want to hear what you think. Drop your take in the comments below, because this is exactly the kind of debate this channel exists for. If a plane that was literally born out of walking away from one foreign partner still needs American technology just to think and process information, how much of this independence narrative is actually real? And how much of it is careful public relations layered over a much messier, more interdependent reality, the kind of reality that might explain exactly why Airbus hasn't publicly panicked yet, even if insiders reportedly are? That question gets even sharper the moment you zoom out and look at the broader engine race happening across the industry right now, because China isn't the only country chasing this exact same dream of true aviation self-sufficiency. Russia has been pursuing its own homegrown alternative for years now, an engine called the PD-35, developed specifically to power large wide-body aircraft without relying on any Western supplier whatsoever. So here's the question worth asking. Who is actually closer to achieving a truly independent, fully domestic wide-body engine right now? Is it China, the country that just lost its original Russian partner and is racing to fill that gap with the CJ2000? Or is it Russia itself, the country that has spent decades building large aircraft engines, but is now operating under some of the harshest technology restrictions in the world? That comparison, China versus Russia in the race for genuine engine independence, is exactly the story we're breaking down next, and it may tell us even more about how nervous Airbus and Boeing should really be. Before we get there, if you've made it this far, take a second to hit that subscribe button, because we cover stories exactly like this one every single day, from Boeing and Airbus to COMAC and every other player, quietly reshaping the future of commercial aviation. And to everyone already subscribed, genuinely, thank you for being part of this community and following along with these deep dives week after week. Your support is the reason we can keep digging into stories like this one instead of just repeating the same press release headlines everyone else in this space recycles. So here's where that leaves us. China just made a quiet, almost invisible move on the C929 program, inviting outside certification expertise into its process for the very first time in the program's history. It's not a flashy announcement. It didn't come with a dramatic unveiling or a ribbon-cutting ceremony. But if you understand how aviation certification actually works, how much credibility matters in this industry, and how long the road to international market access really is, you start to realize this quiet move might be one of the most important milestones in the entire C929 story so far. Airbus certainly seems to think so, because behind closed doors, industry insiders suggest Toulouse is watching this development far more closely and far more anxiously than the company would ever publicly admit. The question now isn't whether China can eventually build a wide-body jet capable of matching Western engineering on paper. The real question is whether the rest of the world and airlines that have spent decades trusting Airbus's own certificates will ever fully trust the stamp of approval behind this new competitor. And that answer is still being written, one quiet regulatory agreement at a time. The video breaking down the Russia comparison is coming right up next, so make sure you don't miss it. Subscribe now, and I'll see you in the next one.